So we were trying to mimic the way that human vertebrae worked. And then these red cords here are like the muscles. There were 6 motors on this as well. So enormously big and bulky. Problem is that we have these incredibly effective actuators. Human muscle has this huge power density and very, very fine force control. This one in front of me is a version 2. So on paper, this looked kind of cool, and I drew it all out, and I came back into work, and I talked with a mechanical design team and said, hey guys, can you turn this into reality? And it just didn't barely move at all. And then we realized there was so much friction in all of this complexity, in all of this kind of cable drive in here, that just all the power of the motors was lost in this drive. So I spent maybe 3-4 months just working on this, and then you just, at the end of it, it's just like, wow, doesn't work at all, start again. I think we actually went through 7 different versions. By the time we got to this one, we dropped the idea of having 7 vertebrae because we realized you couldn't actually see it.
Should you pursue robotics software engineering, as a lot of influencers, including me, have talked about, or should you be pursuing mechanical engineering in the robotics domain? So, if you're excited about mechanical engineering and if you like to build things from scratch, you would like to play hands-on with a lot of different mechanical components, you enjoy that process more than software engineering, you might be a bit confused because a lot of the ideas that are being thrown around uh, prioritize or encourage you to pursue software engineering instead of mechanical engineering, and maybe you're not intrinsically motivated to pursue software engineering, but you see that software engineers get paid more as compared to mechanical engineering and that is absolutely true. This is how it is in industries pay more to software engineers as compared to mechanical engineers, and also there are more job opportunities in robotic software engineering as compared to mechanical engineering overall, if we compare all the jobs that are available in the robotics domain. And these are true. Now all of these things are based on real facts and how the companies hire and the open positions in the robotics companies, but that should not really persuade you or prevent you from pursuing mechanical engineering if you're really passionate about robotics mechanical engineering. Because if you want to pursue robotics mechanical engineering, first of all realize that this domain is narrower as compared to robotics software engineering. There are a lot of exciting subdomains within robotics software engineering. You could work with perception, computer vision, machine learning, controls, planning, and a lot of different kinds of components within the robotic system. Whereas in mechanical engineering, you would be working on a sub system that deals with mechanical design or mechanism design, kinematics and dynamics, computational fluid dynamics, or finite element analysis, or uh, things of that nature. But the number of options that you have in robotics mechanical engineering are less as compared to robotics software engineering, and that can actually be a positive thing, because then you are working in a narrow niche where there are less job opportunities, but there are also less people applying for these positions. So you can establish yourself as an expert in robotics mechanical engineering and cultivate the skill set and work as a robotics mechanical engineer, especially if you realize that you enjoy the mechanical engineering process more than the software development process. So in this video I'll be giving you a step-by-step guide on how to become a robotics mechanical engineer. So let's get started. Become a self-taught robotics mechanical engineer. In this video, I'll be giving you a step-by-step guide on how to become a robotics mechanical engineer. I'll be sharing with you the tools and the resources that you can follow to learn mechanical engineering. So first of all, let me talk a little bit about my previous career path, and I've talked about the fact that I transitioned from mechanical engineering to robotics in some of my previous videos. So let me briefly mention that I have actually worked as a mechanical design engineer for 2 years at an automotive company, and during my bachelor's in manufacturing process and automation engineering at NSIT New Delhi, I was mainly involved in mechanical design projects. I was always interested in mechanical engineering before I actually transitioned to robotics software engineering. So I did a lot of projects during my bachelor's. I was mainly interested in automotive engineering, and I created an off-road vehicle and participated in Baja SAE. I also created a human-powered vehicle and participated in human-powered vehicle challenge. Then for my bachelor's project, I actually designed and developed a novel concept of motorcycle ambulance. So this was another mechanical engineering related project. And then I worked extensively with CATIA, which is design, computer aided design software. And this is also what I worked with at the company for 2 years. So I primarily worked on these projects, and additionally, I did some other mechatronics or robotics related projects, such as building a coil winding machine and building a 2 degree of freedom robotics robot arm. And I've designed and developed a license garnish for an automotive model, and I was involved in fit and finish improvement around the trunk area of 2018 model base. So these are a few things that I worked on. So the reason why I mentioned this is because I want to highlight the fact that I actually worked as a mechanical design engineer before, so I have sufficient experience to really guide you how you can learn mechanical engineering, what are the topics that you should be focusing on, what is the best way to learn mechanical engineering in an efficient manner. And I'll be linking that to my current experience in robotics and what it makes sense to learn in mechanical engineering that is applicable to robotics. So I did all of these projects, and I have actually created a video titled "How I Transitioned from Mechanical Engineering to Robotics," and on this channel, Learn Robotics and AI. So you can go ahead and watch that if you're interested in the software side of robotics. And in this video, I'll be continuing with the mechanical side of robotics. So I developed skills in CATIA, which is a design uh, software, computer aided design software, and then I worked with product development, mechanical design concepts, mechatronic systems, and things of that nature. And in order for you to really make a transition or to just start with becoming a robotics mechanical engineer, the first step that you should be taking is to define your core motivation. Now, this step is basically the same as I mentioned in my other videos, where I give you a guide, a step-by-step guide on how you can become a robotics software engineer. And this is equally valid for robotics mechanical engineering, because in order to pursue any career, you first have to be absolutely sure that this is the right path for you, and that you're pursuing it for the right reason. So as I mentioned, if you see that everyone else is pursuing software engineering and there's more money in software engineering and there are more job opportunities, but you do not enjoy the software development process, then I don't think it makes sense for you to pursue robotics software engineering. And if you like mechanical engineering, you should absolutely go for it. There are still plenty of job opportunities and interesting things that you can work on within the robotics domain. Okay, so watch this video titled Top Reasons to Study Robotics and also Top Reasons Not to Study Robotics on my YouTube channel. And once you have done that, once you are absolutely sure that you have a strong clarity, you have a sufficient enough clarity to really decide that you want to learn mechanical engineering, then go ahead and build a strong mathematics foundation. And this step is also the same as software engineering. So you still need you still need mathematics foundation, and I'd encourage you to watch this course and go through it. Then step number 3 is to learn the mechanical design process. So there's one particular resource that is not very popular, but I absolutely enjoyed referring to this resource when I was actively involved in mechanical design, and this is called Fundamentals of Design by MIT. So this is a series by Professor Alex Slocum. You can simply Google Fundamentals of Design, and you'd be able to find good resources here. And this covers a lot of concepts and topics in mechanical design, and it talks about how to design several mechanical design concepts. But in this step, I want you to focus on the overall mechanical design process. And this is something that Professor Alex Slocum, who is the instructor for this course, talks about in a lot of detail, and he has a systematic process that they teach at MIT, a step-by-step way of defining the functional requirements and other steps in the overall design pipeline. So I encourage you to go ahead and be really familiar with this overall mechanical design process, because this is very specific, and then you can go ahead and learn individual components and how to further design different components. So this is one very useful resource. And then there are a few books that I can also recommend if you want to learn about the product design process, especially mechanical design process. So this is Product Design and Development by Carl T. Ulrich and Stephen Eppinger. So this is one book, and then there's this book called The Art of Product Design, Changing How Things Get Made. So you don't have to go through the entire books, just go through the sections where they talk about the process and get familiar with the steps involved in a mechanical design or product design process. All right, once you've done that, you need to learn kinematics, dynamics, and mechanism design. Now this is an aspect of mechanical engineering that is more related to robotics. Kinematics and dynamics, as you have probably heard of, is really useful in robot manipulator systems and also mobile robots, and in general when it comes to robotics. And also mechanism design is useful for designing the grippers or end effectors for a robotic system. So that is why this is something that you absolutely should be learning as a fourth step. Okay, so for this, I used to refer to these books when I was really interested in mechanism design and understanding different mechanisms and simulating them on different design software. So this is a book called Design of Machinery by Robert L. Norton. This is a pretty comprehensive book on kinematics and dynamics and mechanism synthesis and analysis. So synthesis is actually designing a mechanism from scratch, and analysis is performing uh, force analysis and understanding how forces and uh, different movements are performed. So it is more about analyzing the machines and the systems. So both of these things are important: synthesis and analysis. And a lot of books do not really talk about synthesis of machines and mechanisms. So this is a book that I highly recommend you follow. And also it covers the mechanical design process in a lot of detail, and it is explained really well. And there's a lot of lists of projects that you can refer this book for to as well. And the other one that you can find inspiration from is Mechanisms and Mechanical Devices by Neil Sclater. So this has a lot of inspiring mechanism ideas that you can refer to and maybe try to animate or simulate in different design softwares, or try to do analysis on them and understand how the movements work, what are the velocities of each of the links, each of the components in the system, what are the forces that are acting and how those are transformed. So this is a really interesting resource as well. And as step 5, of course, you need to learn a CAD software. I used CATIA for my projects when I was involved in mechanical engineering, mechanical design, or you can also use Solidworks or AutoCAD. So it doesn't matter which software you use, make sure you spend some time getting familiar with the, the CAD framework, because a lot of these skills that you learn on just one CAD software, they are transferable to another CAD software. So if you learn SolidWorks and then if you decide to, if you work at a company that uses CATIA, you can still adapt to that. Most of the tools would be more or less the same. Of course, you might need to spend some time getting familiar with the interface and things like that, but the overall idea of the tools that are in embedded in a CAD software is more or less the same. Okay, so you need to be familiar with both 2D drawings and 3D design. So for 2D drawings, DXF and DWG are the formats, and these are things that you can work with and design drawings in a general CAD software. It could be CATIA, SolidWorks, AutoCAD, or whichever one you choose. And you need to be familiar with other 3D formats such as STEP, IGES, STL, and OBJ. You need to work with these formats, learn how to import and export them, save CAD models in different formats and transform them, and things of that nature. So STL and OBJ are used for 3D printing, whereas STEP and IGES are used for CNC machining components, sheet metal components, injection molding, but also more general 3D components. And here's the resource that you would benefit from on the channel, Vertinux, and he has SolidWorks beginners complete college course. So you can actually go ahead and watch this series on his YouTube channel, and this is a pretty well made series. And the reason why I'm giving you SolidWorks resources, of course, you can go ahead and learn CATIA as well or other tools, but SolidWorks is the easiest to get started with. And if you are new to mechanical engineering or mechanical design or CAD, SolidWorks would be a really good start because it has a nice user interface. It is easy to get familiar with. Then there are a lot of resources on My SolidWorks. Here is where you can find a lot of tutorials, articles, and video lessons. And then once you've done that, you need to learn the theoretical aspects of mechanical engineering. You need to learn solid mechanics, material science, failure theory, and finite element analysis. You need to know all of these things. And I have two really comprehensive books for you. One is Machine Design, also by Robert L. Norton. This is another book by Robert L. Norton. The other one was Design of Machinery. This one talks about stress, strain, and other structural components of mechanical design. And the other one is Shigley's Mechanical Engineering Design. And I extensively used all of these resources when I was studying for mechanical engineering subjects and also designing mechanical engineering components. The other two books that I would recommend you go through are Fundamentals of Finite Element Analysis, especially if you're interested in CAE, Computer Aided Engineering. And the other one is if you're interested in structures and you want a more general semi-technical view of structural design. There's this book called Structures or Why Things Don't Fall Down by Gordon. So this is something that you can absolutely refer to. Then you also need to learn geometric dimensioning and tolerancing, GDNT. And here's a video series or video on the YouTube channel, The Efficient Engineer. So this is something that you can definitely refer to. It is understanding geometric dimensioning and tolerancing. Okay, then the next step is you need to learn a little bit of programming. And even though you are aiming to be a robotics mechanical engineering, it does help that you have a certain level of exposure to software, because learning software, it also helps you develop your problem solving abilities and thinking abilities to really structure and organize things, and that would uh, essentially be a valuable asset to your mechanical engineering knowledge and skill set. And especially nowadays, everyone should actually learn a little bit of machine learning, but at least learn some general programming. So at least learn MATLAB. It is also used in testing, and a lot of mechanical engineering engineers actually use MATLAB and Simulink as well. So spend some time getting familiar with MATLAB and Simulink. And to do that, you can go on Free Code Camp, and they have a long video titled MATLAB Crash Course that you should just follow. And you can go ahead and watch this video, pause the video at multiple time steps in the video, and really try to do these things, practice the programs, practice the commands, because that is how you learn programming the best. All right, then for Simulink, there's a official MATLAB series called Getting Started with Simulink on MATLAB YouTube channel. So this is something that you can absolutely refer to. And step number 9 is to define projects based on your own curiosity. And I've talked about this in my video on Learn Robotics and AI, on how you can actually specifically design projects that are interesting to you, because you don't want to do projects that you do not find interesting, because mechanical engineering projects also require a lot of hardware. And make sure to choose the projects that you find interesting, but that also the projects that are feasible within the time duration that you have available for the project. So if you have 3 months available, choose a project that can be done within that span. If you have more time, you can choose a slightly more complex project, but the project should be more or less aligned with your interests. So watch this video, and I've given you a step-by-step process on how to do a particular activity that will help you define projects based on your own curiosity. Okay, and to get project ideas, there's another really long video that I've created on my channel, and the video is called Top 60 Plus Open Source Robots. And this is something that you can refer to for electronics projects, for software projects, or also mechanical projects. So these are robotics projects, robotics open source projects or robotic systems. And this should give you a lot of idea of the kind of projects that you can work with. You can build these components from scratch, or you can even buy a kit and try to play with it, modify it, and come up with new ideas to really develop something more interesting in the mechanical side of robotics. Okay, so once you have generated ideas based on your own interest, you need to work on projects in different domains. So this step is in a way similar to robotic software engineering. In robotic software engineering, I encourage you to work on perception, work on a mini project in perception, work on a mini project in control, work on a project in planning and other domains within robotic software engineering, and really try to identify which domain you are interested in. In mechanical engineering, the subdomains can be a bit narrow, but you still need to work on projects in different domains and really identify your narrow niche in which you want to gain expertise in. And for this, I've talked about a lot of different subfields within robotics, and also about subfields in robotics mechanical engineering. You can go ahead and watch this video titled Top Subfields in Robotics on my YouTube channel. And here are four major subfields in the mechanical side of robotics. There's mechanical design, there's modeling and simulation, there's kinematics and dynamics, manufacturing, and of course there can be specializations here as well. There's computer aided engineering, computer aided design, computer aided manufacturing, which are more at the intersection of mechanical engineering and computer science, but these are more or less the fields that you would expect to work in. Of course, there's manufacturing engineering as well, and there are other different domains within mechanical engineering. So I would summarize the subdomains within mechanical engineering into these four components. One is more related with the kinematics and dynamics side of robotics. This is robot gripper or mechanism design, and this also might include multi-body dynamics and rigid body dynamics and things of that nature, even compliant mechanisms and things and such topics. Then there's structural design, then there's manufacturing engineering, and modeling and simulation or testing. So you need to do projects in different domains, or optionally do one project that involves all of these components. So you can work on a project that involves structural design, designing of a structure, but also designing of a mechanism, an end effector of a robot arm, for instance, and also involves manufacturing of components. This could be 3D printing, injection molding, on any of the manufacturing processes that are used. But get familiar with that. And then also, of course, modeling and simulation, which we have already talked about in one of the previous steps, where I told you that you should be learning MATLAB and Simulink. All right, so the next step is to define your niche. Once you have really gained a little bit of understanding of different domains within robotics mechanical engineering, you need to define your niche. And to define your niche, you need to see what are the kind of tools that are used in the domain or the subdomain of your interest, and see if you really find that interesting. Make sure to analyze your strengths and the things that you find important and interesting, and make sure that there is enough job opportunities in the things that you choose. Of course, there are job opportunities in mechanical engineering, but choose a subdomain that you find really interesting, that you enjoy working with. Make sure it's interesting to you and it's aligned with your strengths, and that it has sufficient job opportunities, and that you can have a significant impact by working in that field. So to define your niche, you should identify the kind of activities that really bring you into a flow state. I've talked about this in a lot of my other videos, so I wouldn't go into too much detail, but you have to essentially balance your skill level and challenge level. So for example, when you're designing a mechanical component, initially your skill level might be low, and hence the difficulty of the problem, the mechanical design problem, would be higher, and you would be more on the left side of this graph, where you'd be worried and anxious and stressed out and won't be able to make progress. And on the other hand, if you already have a certain level of skill set, then things would be too easy and you would not be enjoying the process too much. You'd get bored too quickly. And the idea is to have an optimal balance of challenge and skills, and then you would experience something that is called flow state. And this is something that a lot of people who are designing and creating mechanical components also experience on a consistent basis. So this mechanical engineering and mechanical design process is also conducive to flow. I'd also like to mention that you can watch the video titled The Ultimate Robotics Career Guide. There I have talked about how to define your niche and what are the things that you should be focusing on when choosing a career, what are the different career paths, job opportunities, in my video titled The Ultimate Robotics Career Guide. So go ahead and watch that. Then step number 16 is to do more projects in your chosen niche. To gain more project experience, you can refer to the process of building machines. One of the books is actually designed more for hobbyists and inventors. It's called Making Things Move. But this really gives you a practical guide on how you can start building hands-on mechanical products or mechanical systems. And then there's 1800 mechanical movements, devices, and appliances. This is something that you can use with the Neil Sclater book. to gain inspiration on what are the things that you would be interested in making, and also how you can really make that. Then build a portfolio of projects, build just compile all of the projects that you have done in a systematic manner, and you can also refer to the portfolio that I have actually shared on my LinkedIn account. And this is something that would give you a certain level of exposure to what is a good portfolio. But essentially, you should just compile the kind of projects that you have done and really think about how you can showcase it. Then create a strong CV and prepare for interviews. Here's my CV. It's also available on LinkedIn for you to refer to. There's a template available as well. So go ahead and follow this. And of course, your experience would be more or less related to mechanical related projects, and you would be presenting those in your CV. And finally, you can apply for jobs. There's mechanical design engineering jobs which require you to have CAD experience and CAM experience, CAE, finite element analysis, design for manufacturing. You need to know material selection, material science as well. And then there are some other paths that you can take, such as quality assurance engineer, quality control, FMEA, GDNT, and things of that nature, root cause analysis. These are the topics that you would be working with if you choose to work in quality assurance engineering. Then there's manufacturing engineering, where you need to know production planning, Six Sigma, lean manufacturing, and you need to have a good understanding of manufacturing processes, process optimization, supply chain management, and things of that nature. Product development engineer, you need to know how to create prototypes. You need to know quality control, cost analysis, material selection, and also about product design and manufacturing processes. Then there's a list of companies, robotics companies that I have compiled in the form of blog articles on the website Learn Robotics and AI. And there's also a video on the YouTube channel titled Top Robotics Companies in Germany. So go ahead and refer to my YouTube channel and also on the blog to really identify what are the different companies that you can apply to. And there's a lot of free blog articles and meetup recordings and courses and a lot of things that are available on the website learnroboticsandai.com. Finally, if you are interested in becoming a robotics software engineer, I have actually created a course titled Become a Self-Taught Robotics Software Engineer. You can also gain access to the course on learnroboticsandai.com/challenges. So this is the link that you can refer to and go to really see if this is something that you're interested in. There's a detailed compilation of frequently asked questions related to the course, and also about what are the modules of the course, a brief description of the different things that you would expect to learn there. Okay, so that is it. This is how you can actually learn to become a robotics mechanical engineer. This is a step-by-step guide, and remember that these try to follow these steps sequentially, and a significant amount of your effort would be spent on uh, building the projects. Of course, build the foundation, go through the books, learn the design process, learn CAE, learn CAD tools, but spend a vast majority of your time building projects, playing with hardware, doing hands-on tasks, because mechanical engineering is very hands-on, as you already know. So I wish you all the best, and hopefully you find this video helpful.